today we learned about circles. The definition of a circle is all points that are equidistant from the center. So let's say we wanted to draw something in which all points are equidistant from the center. So this is a fixed distance. Let's say it's 1 inch. And then this is the line, right? And we want to make another line. So if I connected all of these points that are 1 inch away from the center, I would get, don't know what I was doing with these over here. I would get a circle. Okay? So a circle is all points that are equidistant from the center of a circle. So if you think of the edge of a circle as 1,000 million little different points that are all the same distance from the center. Okay? That is what a circle is. So if we rewrote this circle over here, so it's neat. Well, that's not good. We would have E as the center. The chord is defined as a line segment where both endpoints are on the circle. So if I have an endpoint here, and I have an endpoint here, and I create a segment, this will be a chord. A diameter is a chord that passes through the middle. So remember, a chord has one segment on this side of the circle, its other endpoint on the other side of the circle, and it passes through the center. So this is a diameter. And then a radius is a line segment that has one endpoint on the center and one endpoint on the circle. So that is a radius. Now, there are some formulas we can use in order to find parts of a circle. The diameter formula is 2 times the radius. So if you think about a circle, and this is the radius, it only makes sense that a diameter would be 2 times the radius, right? So this is the equation for diameter, 2 times the radius. The area of a circle, or the space that it takes to cover a circle, so if you have a circle, you're trying to find the area, it would be pi r squared. So let's say this is the radius. We would square the radius and multiply it by pi, and that's how you would get this formula. The circumference of a circle is the length around a circle. So if this is your circle, and you took a string and you wrapped it around the edge, and then laid that string out and measured it, you would get the circumference of a circle. And then pi is a constant that is 3.14 that we use to multiply in all circle formulas. Now, I think something that would be very helpful for you every time you do circle problems is to write these 3 formulas at the top of the page every time. Diameter equals 2 times the radius, area equals pi r squared, and circumference equals 2 pi r. Because then when you get a problem, like number 9 on page 134, you have your given info right here, you match the number that you're trying to find with the equation up here. So they give me C, so I find the circumference up here. The equation is C equals 2 pi r. You always want to solve for radius first, because radius is the foundation of all 3 of these equations. See, radius is in diameter, radius is in area, and radius is in circumference. So let's find the radius first. Now, if they give us that circumference equals 76.4, and we know from our equation that circumference equals 2 pi r, we can just substitute the value given for C. and we get 76.4 equals 2 pi r. We want to get r by itself, so we divide both sides by 2 pi. And remember what Ms. G said about dividing by 2 pi in your calculator. Make sure that you put the 2 pi in parentheses. And we get the radius is 12.1. So r is 12.1. Now they also ask us for the diameter. So if we need d, we're going to have to look up the equation for d, which is up here, and it says d, or diameter, equals 2r. We have r, we just found it, it's over here. So I'm going to plug that into my equation, and I get d equals 2 times 12.1. 12.1 times 2 is 24. In the book it says 24, in the packet it says 24.3, but that's just because we rounded early. We're going to get 24.2, but the answer is 24.3. So we get diameter equals 24.2. Let's do one more practice problem. So on page 135, number 2, it says there are 2 circles. The area of the large circle is 36 times the area of the small circle. The radius of the large circle is how many times the radius of the small circle? Okay, so we don't know the radius of the large circle, and we don't know the radius of the small circle. But let's just draw our picture anyway. So we have our small circle with an unknown radius. We have our large circle with an unknown radius. What we do know is that the area of the small circle, the area of the large circle is 36 times the area of the small circle. So let's say the area of the large circle equals 36 pi. Therefore, the area of the small circle would have to equal pi. Now, how is this possible? Well, the formula for area is area equals pi r squared. Okay, so the formula for area is pi r squared. So if the area of the smaller circle equals pi, and the area of a circle is pi r squared, we know that we can plug the area in to A for the equation, and we get pi equals pi r squared. So we divide both sides by pi. Anything divided by itself is 1 equals r squared. Square root both sides to get r alone, and we get r equals 1. So the radius of the small circle is going to be 1. Let's do the same thing for the large circle. We know that the area of the large circle is 36 pi, and we know the equation for the area of a circle is pi r squared. So I plugged the area over here in for A in the equation, and I have 36 pi equals pi r squared. I'm going to divide both sides by pi. Pi cancels. We get 36 equals r squared. I square root both sides to get rid of the square, and I get r equals 6. So the radius of the large circle is going to be 6. Now I read the question. The radius of the large circle is how many times? Remember, how many times? How many times means divide. So the radius of the large circle, I'm going to draw a capital A because that's a large circle, divided by the radius of the small circle. I'm going to draw a lowercase a so I know. So it's going to have to be the radius of the large circle divided by the radius of the small circle. The radius of the large circle is 6. The radius of the small circle is 1. The answer is 6. The radius of the large circle is 6 times the radius of the small circle.